Given question, the 12-meter boom CD weighs 10 Newton. The distance of center of gravity G 6 meter from hinge C. For the position shown, determine tension T in the cable DE and the reaction at hinge C.
Let us understand given question with the help of diagram. Beam CD is hinged at point C and the angle of inclination is 30 degree. At point D, weight 24.9 Newton is connected, which is acting in vertically downward direction. Weight of beam CD is given 10 Newton and it is acting to the center of gravity point G. And the distance in between C and G is mentioned in the question 6 meter. So for this beam CD, point G is the middle point. So distance in between G and D is also equal to 6 meter. We have to find out tension T developed in the cable ED. Here the cable ED is making an angle 15 degree with beam CD. We have to also find out reaction developed at the hinge C. We will first draw the free body diagram. So for that we will first take this beam CD. Now this beam CD is making an angle of 30 degree with horizontal. Now if I draw the same horizontal line passing through this point D, then here also we have to show opposite angle and it is equal to 30 degree. We have to find out tension developed in the cable E to D. So this cable is connected at point D. Tension we have to show which is in the outward direction from this point D. So we will show here the tension developed in the cable ED. And this tension is T and direction is outward direction from this point T. So why the direction is in the outward direction? Because this cable is extensible. So for this point D we have to show direction in the outward direction. And this cable ED is making an angle of 15 degree with this beam CD. We have to show weight. Weight of the beam CD is mentioned 10 Newton and it is acting to the center of gravity point. So we will show here in vertically downward direction 10 Newton force. Then the weight is also connected at point D 24.9 Newton and it is also acting in vertically downward direction. Now we will move to find out the tension T developed in the cable. Beam CD is hinged at point C and we have to find out reaction developed at this point C. So how to find out? So we will first take its a horizontal component and vertical component of this reaction at this point C. Because this point C is hinged, that means it is free to rotate. That is, this beam CD is free to rotate about this point C. So to find out the reaction developed at this point C, we have to first find out horizontal component and vertical component of the reaction. So horizontal component we have to show direction towards this point C, and for vertical component also we have to show direction towards point C. So this horizontal component we will say it is Rx and vertical component we will say it is Ry. Now we will find out Rx and Ry to find out the reaction at this hinge C. Now we will first take the moment of all these forces about this point C is equal to 0. Now why to apply this condition? Because we will consider this whole system is in equilibrium. So when the system is in equilibrium, then the moment of all the forces about any point is equal to 0. Summation of all horizontal forces is equal to 0 and summation of all vertical forces is equal to 0. So we will apply the equilibrium of this whole system and moment of all the forces about this point C is equal to 0. Now this Rx and Ry are acting at point C. So its a moment or about point C is equal to 0. Now we will move to the next, that is this tension T. So we have to take this force multiplied by the perpendicular distance. So how to find out perpendicular distance? So first I will take the line of action of force. That is, I will extend this tension T. Then we have to find out perpendicular distance. So perpendicular distance from this point C, that means we have to show here one perpendicular line and this distance we have to find out. So if we observe, here is the triangle. So suppose I will say this point is X, then CDX is the triangle. And we have to find out this perpendicular distance. So how to find out? So this CD is known. That is 6 plus 6, 12, and this angle is also known, that is 15 degrees. So this side is opposite to this angle 15. So we can say that this distance CX is equal to 12 sine of 15. So we can say that how to take the moment, that is force multiplied by perpendicular distance. Now if I move the compass about the point C in the direction of T, that is in this direction, then this direction is anti-clockwise direction, and for this I will consider here negative sign. So minus T multiplied by 12 sine of 15. Now we will move to the next, that is this force 24.9. So how to find out perpendicular distance? So I will show here the line of action of force. And if I extend this, then here is the perpendicular distance. So suppose we will consider this point Y. Then here we have to find out this distance CY. So in this triangle CDY, how to find out this? It is nearby to angle 30 degree. So we can say that it is equal to, this whole distance CD is known, 12 cos of 30. And this 24.9, that is force multiplied by perpendicular distance. Now if I move the compass in the direction of this CD, that is here, it is clockwise direction and we have to consider positive sign. So plus 24.9 multiplied by 12 cos of 30. Now in the same way we will move for the 10 Newton. So for 10 Newton we have to find out, here is the line of action, here is the perpendicular distance. So suppose this point we will consider Z. Then in triangle CGZ we have to find out this side. So it is equal to CG is 6 cos of 30 multiplied by 10. Now if I move the compass about the point C in the direction of 10, then it is in the clockwise direction. So we have to consider positive sign. That is plus 10 into 6 cos of 30. Now when we solve this, which is equal to 0, so right hand side is equal to 0. So when we solve this, we will get T is equal to 100 Newton. So this is the answer of first question, that we have to find out tension T. Now we have to find out reaction developed at point C. So we will first find out Rx and Ry. So how to find out Rx? That is the summation of all horizontal forces is equal to 0. Now if we observe in this system, how many horizontal forces? So T is inclined. So we will resolve this T. So I will resolve this T into two components. So first horizontal component and here vertical component. So horizontal component, if we observe from this T, angle is equal to 15 degrees. So here 30 minus 15, that is 15. So here we can say that it is T cos of 15. And here for vertical component T sine of 15. Now for all summation of all horizontal forces, that is Rx is acting towards right hand side direction, T t cos 15 acting towards the left hand side direction. So Rx minus t cos 15 is equal to 0 and therefore Rx is equal to 96.9 Newton. Now we will find out Ry. So for that, summation of all vertical forces is equal to 0. So Ry is in the upward direction. So we will take positive sign plus Ry minus 10 minus 24.9 minus t sine 15. So Ry is equal to 60.9 Newton. Rx is having positive magnitude. While calculation, we have considered the direction is in the forward direction or towards the right hand side for the positive sign. So we have to show Rx direction is towards the right hand side. Ry is also having positive magnitude and for the upward direction we have considered positive sign. So Ry is having direction is in the upward direction. Now we will find out the resultant or reaction for these two components. So we will first plot this Rx as well as Ry. So in the same way, that is the direction of Rx is towards the right hand side. Here is Rx and Ry is in the upward direction. So here is Rx and Ry. So how to show the resultant R? So we have to show the angle arrow is towards the arrow meeting for this Rx and Ry. So here is the reaction R. We will calculate magnitude for this resultant R, and that is equal to under root of Rx square plus Ry square, and which is equal to 114.5 Newton. Now how to find out its direction? So for that we will consider here the angle in between Rx and R is equal to alpha. Now if I make here one construction, then we will consider this triangle. So this vertical line is equal to Ry. So in this triangle we will say here point A, B and C. In the triangle ABC, tan of alpha is equal to Ry by Rx and the magnitude is known, and therefore alpha is equal to tan inverse of Ry by Rx, and which is equal to 32 degrees.